My name's David Hodgetts and I'm from VRGS Science Limited. I have been working on using digital outcrop data for quite a few years, over 20 years now, in digital outcrops in one form or another, through early days of using differential GPS, through using LiDAR, to more recently using photogrammetry. I developed VRGS because as an academic, I worked at the University of Manchester for 20 years. We had all of this digital outcrop data, geological data that we couldn't really do what we wanted with. So I started to develop the software that enabled us as geoscientists to make the kind of analysis that we want to make on digital data. Now, what I'm going to do for this first session, we're going to look at a outcrop from Earth. But I just want to do this so that you can get a feel for the kind of things that we can do with this kind of data. So what we've got on the screen now is VRGS. It's a Windows application. So unfortunately, if you're a Mac user, then we don't have, you just have to find yourself a Windows machine. It's written in C++. And the priority on the main focus of the software is to be able to analyze data, but it also allows you to visualize your data on desktop in 3D, and you can connect to VR as well. So quite easily click on a button and jump into VR on your headset. And when you're in the headset, you can just unclick another button and you come back into the application. So very easy to jump between the two. Right, we're going to start by creating a new project on this one. So I've got some data set up in here ready to go. So we just create a new project. And once you've got your data, your project started, to load your data, I'm using OBJ format, which is pretty much a standard format, but it'll take LAS files, ASCII files, GeoTIFFs, all kinds of different data. So we just drag and drop our OBJ file into the 3D view. And it pulls in, does a bit of processing on it. And the way that I developed VRGS was that it does a lot of restructuring the data as it imports it to try and make the analysis and the visualization as quick as possible. So it's just doing a bit of pre-processing, optimizing the mesh, making sure everything is linked correctly, writing it to the disk. And then do a little bit more processing on the first display. And there we go. And that's brought in a digital outcrop model. Can I just check with everybody that the display is okay? Is not too laggy or anything like that?
Yes.
Yes.
Good. All right. That's good to know. Just making sure. Right. So we're looking at the Jurassic in Staithes, which is in northeast England. And these are this is the Cleveland Ironstone Formation. Geology itself, it's really interesting geology here, but it's not this geology isn't what we're focusing on. We're focusing on what we can do with the tools that we have. Right. Now this data is already georeferenced. If your data isn't georeferenced, we have tools that you can use to put your georeferencing in there. Now the first thing that you would ask when you look at this, we can see is a fault. We can see the ironstones in there. There's some nice fractures. First thing we say though is, how big is this? We have no idea what the size of this model is. So let's put a scale bar in. Virtual scale bar. There's a 5-meter scale bar. We can modify that, make it different size. So if we wanted to say, let's have a 10-meter scale bar, and it's got 5 segments to it, so it's 10 meters. We should have 10 segments. We can change it to be a square. move, so look at it, or if you want to make it horizontal. And then finally, we can have triaxial. So that's triaxial horizontal. If you switch off horizontal, we get a proper triaxial bar. So that just means you can easily put in some scale data and go back to the round view. Get some scale data in there so you can really understand what you're looking at in terms of the size. Right. Now, the next thing that we would want to do here as geoscientists, well, there's a few things we'd want to do, but maybe the first one is what is the orientation of these beds? Now, we're going to be doing this on Mars data from HiRISE, but there are challenges with doing that on what is effectively fairly low resolution elevation data. I'll show you the process for doing it on very high resolution outcrop data. And then as we do the exercises and look at doing the similar interpretation techniques, we need to think about what the limitations are and how do we check our data and how do we go about mitigating those possible errors. Anyway, so here we are. We've got a nice corner to go around. And I use the orientation tool here. I do 1, 2, 3 points, and we've calculated an orientation. Now, if you have 3 points, basic geological problem, the 3-point problem, if you know 3 points, you can that will form a triangle. That triangle forms a plane. You can calculate the orientation. The critical thing with this is that you've got 2 parameters really that affect how accurate that measurement is how linear of those 3 points. So ideally you want an equilateral triangle. So the 3 points will make an equilateral triangle. On a lot of cases, say if you look at an outcrop face like this, say along here, you're going to struggle to get an equilateral triangle from 3 points. So we have to think about that. We have to search around to find areas where we've got enough 3D exposure. Now, if it isn't making an equilateral triangle, it'll still work and you still give us good results. So there's an area here. We could do 1, 2, 3. That's fairly not equilateral, but we can check it and use our geological intuition and use our eyes and make sure that it actually fits in with what we see in the outcrop data around it. So always do a visual check. And the other thing that controls that orientation measurement is how big the triangle is. So if the triangle is nice and big, then you've got fairly accurate measurements. If the triangle is very small, then a slight error can lead in a big error in orientation. But then you've also got the other problem. If you do a very big measurement, that's fine if your beds are all dipping in the same direction. But if you've got folding, then you've got to keep your triangle size small. So there are all these little things that you've got to think about when you're interpreting digital outcrop data, and they all apply to when we're working with elevation data and large scale data like we're going to look at in a bit. Right, so the other thing that as you're building up your geological interpretation, we have an integrated StereoNet view. So as we are putting in these measurements, I'll put in another one here. See that it appears on the StereoNet in real time. Let's find another one, see if we can try and do something around here. And there we go. So as we're building up our interpretations, we can watch what's happening on the StereoNet and we can see what the patterns are as we're doing our interpretation. Right, I've shown you one mode for orientation data. There's a couple of different modes. The default mode is the 3-point mode. That's the quick mode. And it's what most people use sort of on a general basis. But then we've also got this endpoints mode, which instead of just clicking 3 points, we would have to do, let's go around here, do one round here. So I'd do 1, 2, 3, and I can keep going and it's a double click to finish in this case. So it's a little bit more in terms of more clicks and a double click to finish. The 3 points mode finishes when you've done the third point. But what this does is that it allows you to encapsulate or record more data about that orientation measurement. Where it's really useful on digital outcrop models is when you're working with mapping fracture networks, for example. So you might want to delimit the face of a fracture on an outcrop surface. Another very useful mode to know when you're doing your going along with the practical later on is if I'm say looking at something like this and I'm in my interpretation mode, I'm doing 1, 2, 3, and you come here and you say, oh, I need to change the viewpoint, but I'm in an interpretation mode and I can't navigate. If I click, it's going to digitize. You just hold down the shift key and you go back into move navigation mode, and it will allow you to then, once you've released the shift key, carry on interpreting the same object. So we've been able to go around a corner. That's a very useful one to remember. So hold down the shift key while you're interpreting to pause interpretation, navigate the model, release the shift key, and then you can carry on. So that's putting in orientation measurements. The next one we're going to look at is we have digitized faults and digitized polyline. Recommendation from us at the moment from VRGS Science is to do everything with polylines and then label them in groups as whether it's a fault or a bed. So we'll just look at polylines on this one. So polyline, very easy. So we'll go to where we want to draw a polyline. Digitize, make sure that your mouse changes to the right cursor. So this is in polyline interpretation mode, and I'm going to put in one along here. Just keep digitizing, hold down the shift key, move, continue, hold down the shift key again, and just carry on. Double click to finish. And there's our polyline. And you see the polyline has also appeared on the StereoNet. Whenever you create any interpretation, so if I select it and go to properties, sorry, that's something I should have said, how I'm going to refer to the menu system, right? Just in review, this up here, I will refer to, yeah, this up here is the, what I'll refer to as the ribbon bar or the ribbon menu. Then we have on the left-hand side here, we have the interpretations, collections, and data. That's fairly straightforward. Data are things like your meshes, interpretations are things that you've drawn that are interpretations. So there are some things that you put into the model that will stay in data, like scale bars of data rather than interpretation. And then you have this group here, which is called collections. So collections are things that can't be displayed on their own. So you can't display a fasces on its own, for example. It has to be attached to something. It has to be attached to a geobody or to a log, but it's not a physical entity in its own right that you can display as an object. It's a description of this is a bed with this fasces, for example. Then on the right-hand side here, we have the charts tab. That's where we find our StereoNets and our histograms. The properties panel, where we can look at the properties of the individual objects or change their properties of groups and objects. And then we have the web view, which we will use later on. Right. So now when I click on any of these objects, you can see the properties, and we get different measurements for different objects in there. So you see we've now got this polyline, polyline 0, and it's given us an orientation as well. So you might be thinking, well, why do I need to have structural measurements and polylines if they all give the same measurement? Well, structural measurements, you're doing that just to measure structure, right? Just to get an orientation. Polylines, you are measuring, you are mapping the extent of a linear feature. And again, this could be changing dip along its length. So you would then use the polyline to delimit the bed itself, but then you use your individual structural measurements to define the structure. And just a little bit on how we go about editing these. Whenever you select the polyline, you see these vertices appear, these spheres and square and cubes. Right, so the spheres represent your digitized points. So if I hold down the control key and use the mouse wheel, so you need a mouse with a wheel to do this. Otherwise, you can actually go and change these properties in the group properties for the polylines. So we'll just mention that. If you click on a group, you get the group properties, which has things like in here projection distance, so how far this projects from the outcrop, how far your polylines project out. So you see it changed how far it projected out. And then we have, we can switch on the nodes and vertices on and off all the time. We can also change the display to have a 3D trace rather than just a plane. And that's about it on the ones we want to show here. Anyway, so there we go. So you can change your group properties. So that will change the property for all of the polylines. And then you have individual properties as well that you can modify. Right, we want to edit. So I've decided that I've made a mistake somewhere along this line, or I want to tidy it up, or maybe I want to extend it. There's an option in here called move vertices. So I can click on a vertex and just drag it along the outcrop. Yeah, editing is as simple as that. Now, what if I want to add another vertex? That's what these cubes are for. So they're not your original digitized points. They're the center points between your digitized vertices. But if I select that and move, it adds another vertex in on that point that you can then add onto the outcrop and produces two more of these midpoints that you can then go on and edit. If you want to get rid of one, you click it, drag it onto one of the adjacent vertices. It turns red. It says that's telling you it's going to delete it. And then we've got rid of it. So very easy to go in there and edit and manipulate your polylines. So the editing features are in there. What else might we want to look at? So we'll work our way across these. We won't go through everything. The next one we're going to look at, we'll mention the different polylines have different interpretation modes as well. We've just looked at digitized points. So digitized points, I click, and each click puts in a new point. Now, if I click and move the mouse, it only adds a point at where we did the mouse click or button down. So when the button clicks down, that's when you put the point in. It doesn't do anything while you're moving or when you release the button. So that's digitized points. But we've also got in here a thing called the draw mode. Now the draw mode, I'm just holding and dragging the mouse along now, and it's just putting lots of vertices in. And again, double click to finish. And if I select that polyline now, you can see it's put in a vertex, lots of vertices in there compared to this one where it only put in when I clicked. We can get a bit more control on that when in the polyline properties here, we have this thing called the minimum digitizer spacing. So if I change this, it's set to, it will only put a point every 20 centimeters at the moment. Everything in the VRGS menus is in meters. So I stick to SI units as much as possible. There are a few cases where it's asks you for a value in centimeters or in kilometers, but it's very clear when those cases are. It will say on the dialog box or next to it what the values are, right? So anyway, let's change this from being 0.2 to 0.5. So this will only put a point in every 50 centimeters now. I'll do the same thing, digitize, draw. Doing it very quickly, do take a bit more time. See there, we've got a little bit more control, so we're not putting too many points in. You can, as well, if I go back to digitize, to draw, I'll go move out a bit and we'll go along this horizon here. So I'm putting in, if I just press the space bar, I switch modes. So I'm now just having to click shift to turn around the corner. I know that concretion layer goes around here. Press space bar and I'm back into the draw mode. So this polyline, we've swapped modes as we've been doing our interpretation. So very flexible, and you can adapt and use whichever mode you feel is the most appropriate and most useful. As we've been doing them, these have all been going into the interpretations tree. There's ways in here you can change the default name and the naming convention. Once you've got started to put your interpretations together, we can go in here and just do group, and that's put them into a separate group. So that's a good way of being able to keep your interpretations organized. And earlier on, I mentioned that we would normally, or we now say, do everything as polylines rather than using the fault digitizing tool and then label it in here. So let's just quickly do that. We just so happen to have a nice fault that we can look at. Let's put in a interpretation along here. So I'll do a fault interpretation, and I'm just going to put an interpretation down along this part just here. Probably goes down there. And let's put that into the group here. I'm going to then, let's just add another one in. So this has got quite a lot of splays in it. So let's do digitize polyline again.
Yeah, David, and maybe after this, we can move to Martian project and explore other features already.
Yes, yeah. So anyway, now we've got here, yeah, we are about that time. So now we've got here, we can do a group on that, and then you label that as fault. So that covers pretty much all of the basics that you're going to need and shows you how these work on really detailed data. And that will be a very good, and that's a good basis for understanding the process.